2 talks mostly about the math portion that I was discussing. You just finished scientific notation. Now we're going to look at units and why they're important. So we have a system of basically units are our system of measurement. It's kind of like a scale. It gives the number a meaning to represent what kind of measurement we just finished calculating. Scientists require common units, especially for things like mass, length, time, and temperature. There is two main, I would say, systems that we use in the world. One of them is known as the English system, and the other is known as the metric system. And as it says there, that is the basically the unit that we're going to be working with the most. The system that we're going to be working with the most in science because it is kind of a universal system for all scientists around the world. We also have something known as an international system or an SI system. SI, it's units that are set up as an international agreement, especially for things like NASA, things like overall worldwide scientists that use this, uh, physicists, things like that. So these units are based and derived from the metric system. Basically, they all agreed that these are kind of the units that they're going to internationally use. Let me give you an example of some of the SI units, and some of these you're also going to see in our class. So first we have mass. Mass, it's the unit that is internationally used, or the fundamental SI unit is going to be kilogram, and the abbreviation for kilogram is known as kg. Length, we have the unit meter for that, and the abbreviation for that would be a lowercase m. Time is obviously mostly everything in science is usually measured in second, and the abbreviation for second is a lowercase s. Temperature, now I know you're used to Fahrenheit, especially when we talk about how hot or cold it is outside. And however, in science, we use something known as Kelvin, and I will go into why we use Kelvin and not Fahrenheit or Celsius. And the abbreviation for Kelvin is an uppercase K. We're not going to talk too much about electric current since we will cover energy, but it's going to be very, very brief, and it's going to be kind of what I like to say the surface area. So the very top surface of energy. Ampere is the unit, and the abbreviation is A. You'll talk more about that in physics. And the amount of substance. What is amount of substance? Normally, this comes when it's regarding chemicals or molecules because they are so small. So the unit is known as mole, and the abbreviation is just mole without the E. Now, what are some units that are in the metric system? And again, we prefer to use these units compared to the English system. So, prefixes. These are the prefixes that go with the metric unit. So these prefixes kind of change the size of the unit. They can either increase the unit by a lot or decrease the unit by a lot. And we're going to talk about unit conversions pretty soon as well. So mega is a prefix that we can attach basically to anything. We can attach it to gram. We can attach it to second. We can attach it, let me think of another one. We can attach it to meter, and that's another one. So all of these you will we will talk more in detail about these when we talk about unit conversion. So I don't want you to focus too much on this. Lastly, I really want you to read this because this tells you kind of how the importance of why having common units is very important. It's a very interesting read. It's a very short. You have a little short question at the end of your notes, so I really hope you read this. Again, guys, this was section 2. Any questions, please let me know.